Welcome back to my new video lectures. Myself, Professor Pinkesh J. Patel from the Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. The journey of this college started in the field of engineering and technology as per the guideline of AICTE, that is the All India Council for Technical Education, New Delhi in 2004, and MGTER is approved by AICTE New Delhi and affiliated to GTU, that is the Gujarat Technological University, Ahmedabad. The institute is located at South Gujarat in peaceful and pollution-free environment of the western region of the country. The MGTER aims to provide value-based education. The motive behind to provide quality technical education at people's doorstep at an affordable cost. Not only studious activities, but there are many extracurricular activities like state level tech fairs, different sports activities and cultural activity held during the year at MGTER for the overall improvement of the student. So today I will start with the subject of interconnected power system having a subject code of 2170901. So already we have started with the chapter number 2, that is the power system matrices. This is the flow of the contents, that is the examples based on Ybus network and example based on incidence matrix. So already in the last lecture we have started with the example number 1 and we have finishing the example number 1, and in that case we will go for the formulate the Ybus. So today I will start with the example number 2, that is based on the Ybus admittance matrix. So let's start with the example number 2. A sample power system has the following line data from a bus admittance matrix for this system, having a 3 columns. First one, that is the bus code, then series impedance, then per unit line charging admittance Y by 2. So this is the table for the individual line and having a value of series impedance and the line charging admittance that is given over here. This is the actual network, this is given over here, and so from the figure we will say that having a total of 4 buses, bus number 1, 2, 3 and 4, and individual line having a series impedance as well as shunt admittance which is connected over which is already shown inside the figure. So whatever this part, this is considered as a shunt admittance, whereas which is considered as a series impedance. So now we will go for the example, and from this example we have to formulate the Ybus. So now first one, that is considered as a Y12. So now go for the figure Y12. So this is the from 1 to 2 side, 1 to 2, and in between having a value of impedance that is given 0.02 plus j 0.08. This is given over here. So this is the value of impedance. So try to convert it in terms of admittance. So we will write that Y12 that is equal to 1 upon Z12. So 1 upon Z2, just put the value of impedance 0.02 plus j 0.08. So now to remove the denominator term, multiply with the 0.02 minus j 0.08 in the numerator as well as denominator term. So we will get the answer of 2.94 minus j 11.76 per unit. Then after we will go for the next one, that is the Y13. So go for the figure Y13. So Y13 which is connected over here, Y13, and having a value of impedance that is given 0.06 plus j 0.24, that is written from the table. So now go for the calculation of the Y13. So Y13 that is equal to, we will write that Y13 is equal to 1 upon Z13, and value of Z13 that is the 0.06 plus j 0.24. So now to remove the denominator term in terms of j, try to multiply 0.06 minus j 0.24 in the numerator as well as denominator term. So we will get the answer of 0.98 minus j 3.92 per unit. Then after we will go for the next parameter, that is the y23. So now from the figure y23, so y23 which is connected over here and having a value of impedance, that is the 0.04 plus j 0.16. so we will y23, that is equal to, we will write that 1 upon z23 and just put the value of z23, that is equal to 0.04 plus j 0.16. So try to solve the equation. So we will get the answer of 1.47 minus j 5.88 per unit. Then after we will go for the y24 is equal to y23, y24 which is written over here y24, and next one, that is the y24 and y23. So y23 which is y23 and y24, because both having a same parameter and both having a value of impedance, that is again same, and both having a value of shunt admittance, that is again same, 0.025, that is same on the both side. And then after value of series impedance, that is the 0.04 plus 0.16, 0.04 plus 0.16. so that's why which is written as same. So y24 is equal to y23, that is equal to 1.47 minus j 5.88 per unit. Then after we will go for the next one, that is the y34. So y34, that is connected over here, that's part which is considered as y34 and having a value of impedance, that is given 0.01 plus j 0.04. so again y34, that is equal to, we will write that 1 upon z34 and value of z34, that is the impedance, and impedance that is converted in terms of resistance and reactance. So having a value of resistance and reactance, and so from that whatever the value of impedance, that is given 0.01 plus j 0.04. so try to solve the equation. So we will get the answer 5.88 minus j 23.53, that is in terms of per unit. So in the actual, what kind of actual matrix for the Ybus? So Ybus, that is equal to, we will write that first term, that is the that is the first term, that is the y11, second one, that is the y22, then third one, that is the y33, and fourth one, that is the y44. Here that's term, that is the y12, y13, y14, y21, y22, y23, and y34. Likewise, whole value of whole bus, that is considered as a admittance bus. But what is the main important thing, that we will write the equation for y11, this term that is considered as a y11. So how we will write the equation y11, that is equal to y12 plus y13 plus y10, that is important thing. So for that, just go on the figure. So we will write that write the equation for the y11, that is equal to first term, first line, that is connected in between 1 to 2, so that's why which is written as y12. Second one, that is connected in between 1 to 3, so that's why which is written as y13, plus last term, that is the shunt admittance. We will say that that's your shunt admittance and that's your shunt admittance at the bus number 1, so that's why which is written as y10, and both and bus number 1 having a value of shunt admittance which is written as both are different, but if we will make this summation, so we will get the answer, but in actual we will write the equation, that is the y1, fourth term, that is in third term, that is considered as a y10. So y11, that is equal to, we will write the equation y12 plus y13 plus y10. Same way we will write the equation for minus y12 minus y13 and having a 0 term, because there is not any connection in between 1 and 4. So from the figure we will say that there is not any connection in between 1 to 4, so that's why which is written as a 0. Then after here, that's your minus y12. If we will go for the bus number 2, so having a y22 is equal to, this is the equation for y22. So how we will write the equation for y22, that is equal to y12 plus y23 plus y24 plus y20. So for that, go for the figure. So y24 that is y22, that is equal to, we will go for the bus number 2. So there are 4 buses. So firstly we will write the equation for the y22 is equal to first line, that is the y12, plus second line that is 223 y23 plus third one that is y24 and fourth one that is itself y20 because this line that is connected with the ground node also and having a value of shunt admittance which is over here, and we will make them add. So this is the equation for the shunt y22, then minus y23, then minus y24, minus y13, minus y23. Likewise we will write the equation for the y3 bus. So y3 bus having an equation of y13 plus y34 plus y32 plus y30, y13 plus y23 plus y3 plus y34 plus y30 and minus y34. Then here having a value of 0. So because there is not any connection from 4 to 1, there is not any connection from 4 to 1, so that's why y41 that is equal to 0. Then having a value of minus y24, then minus y34, and last one that is the y44. So y44 is equal to, we will write that y43 plus y42 plus y40, y43 y24 plus y34 plus y40. So this is the equation for the shunt y bus. Now we will go for the calculation of the shunt admittance at different buses. So if we will go for the calculation of the y10 over here, so y10 that is equal to we will write that y10 that is equal to, we will write that 0.003 plus j 0.04. So how we will write y10 that is equal to j 0.03 plus j 0.04. So for that, go for the figure. So here first one at the bus number 1 having a first shunt admittance, that is the all individual bus having a whatever the value of shunt admittance that is given, that is the same value, right? So that's why at the bus number 1 first value that is given 0.03, and at from 1 to 3 having a value of shunt admittance, that is this j 0.03, whereas from 1 to 2 having a value of shunt admittance that is given 0.04, that is given over here. So we will make them add, so we will get the answer of 0.07 per unit. Then after go for the second one, that is the y20. So y20 we will go for the y20. So in that case having a total of 3 terms, because first term that is the 0.04, second one 0.025, and third one having a value of 0.025. So that's why y20 that is written as 0.04 plus j 0.025 plus j 0.025. So we will get the answer of j 0.09 per unit. Then y30 that is equal to, now we will go for the y30. So at the bus number 3 having a we will say that having a first one that is the j 0.03, j 0.015, and third one 0.025. So there are 3 buses, that is there are 3 shunt admittance that is connected at the bus number 3. So just put the value of all the value of shunt admittance over there. So y30 that is equal to j 0.03 plus j 0.015 plus j 0.025. So we will get the answer of j 0.07 per unit. And likewise last one, that is the y40. So y40 that is equal to, go for the bus number 4. So from the figure y bus 4, so there are 2 value, first one j 0.015 and second one that is the j 0.25. So 0.025 plus j 0.015. So we will get the answer of j 0.04. So this is the answer for the individual value of the shunt admittance. So now just put the value of all the value of shunt admittance as well as mutual admittance in the y bus in this equation. So we will get the answer for the y bus, that is equal to 3.92 minus j 15.61 minus 2.94 plus j 11.76 minus 0.98 plus j 3.92. then fourth one that is the 0. Then next term that is the minus 2.94 plus j 11.76 then 5.88 minus j 23.43 minus 1.47 plus j 5.88. Then last term, that is the minus 1.47 plus j 5.88. First term minus 0.98 plus j 3.92 minus 1.47 plus j 5.88, 8.33 minus j 33.26 minus 5.88 plus j 23 plus 23.53. And last row having a first term, that is the 0 minus 1.47 plus j 5.88 minus j 5.88 plus j 23.53, and last term, that is the 7.35 minus j 29.37. So this is the required answer of the Ybus for this example. So from this example, we will get the answer of Ybus for the given network. So this is the very complicated network that is given over here, and this is the table for the series impedance as well as shunt admittance that is given over here. And based on that, we will already solve the example and we will get the answer of the Ybus. So this is the finishing of the example number 2. Now we will go for the example number 3 with the different pattern. So let's start with the example number 3. The following figure shows a simple 4-bus system which is asked inside the year of winter 2013. So this is the figure of the and having a 4-bus system. Now the shunt admittance at all the buses are assumed to be negligible. So we have to assume that having a value of shunt admittance, that is 0. Now go for the case number 1. Find Ybus assuming that the dotted line shown dotted is not connected. So inside the case number 1, we have to assume that this line that is not connected over here. And case number 2, in that case, what modification is needs to be carried out in Ybus if the line shown dotted is connected. So if we will go for the case number 2, so in that case we have to be assumed that this line that is connected, this line that is this dotted line that is connected from 1 to 2. So at that time, what is the effect on the new what is the effect on the Ybus? That is considered as new Ybus. So now let's start with the example. So now firstly we will start with the case number 1. In that case, we don't have to consider this dotted line, right? So now firstly we will start with the example. So having a term of mutual self admittance, that is the y13, y23, y24 and y34, that is all the value that is considered as a self admittance. So y13 that is equal to we will try to convert in terms of impedance, because in this example having a value that is given in terms of impedance only. So that's why we will write that y13 is equal to 1 upon z13. So 1 upon just put the value of impedance 0.10 plus j 0.30, that is equal to, we will try to convert in terms of polar form, 0.316 and having an angle of 71.57 degree. So if we will write the answer in terms of polar form, so we will get the answer of 3.165 and having an angle of minus 71.57 degree. So again try to convert in terms of rectangular form. So we will get the answer of 1.0 minus j 3.0. Now go for the second term, that is considered as a y23. So y23 that is equal to 1 upon z23. So just put the value of z23 over here. So this is the value of z23, 0.15 plus j 0.45. Try to solve the equation in terms of polar form. So we will get the answer of 2.109 and having an angle of minus 71.57 degree. And if we will try to convert in terms of rectangular form, so we will get the answer of 0.667 minus j 2.0. Then after we will go for the third term, that is y24. So y24 that is connected in between 2 to 4 and having a value of impedance that is given 0.10 plus j 0.13. So y24 that is equal to, we will write 1 upon z24 that is equal to 1 upon 0.10 plus j 0.13. So we will get the answer of 1.0 minus j 3.0. Then after y34, next term that is considered as a y34. So that's why we will go for the y34. So there is a one line that is connected from 3 to 4 over here. So that's why, and having a value of impedance that is the 0.05 plus j 0.15. So y34 that is equal to, we will write 1 upon z34 that is equal to 1 upon 0.05 plus j 0.15. Try to convert in terms of polar form. So 0.158 and having an angle of 71.57 degree. And final answer that is converted in terms of rectangular form. So we will get the answer of 2.0 minus j 6.0. So this is the answer for the self admittance. Now go for the mutual admittance. So first one that is considered as a y11. So and y11 having an equation of y11 that is equal to y13, because at the y11 if we will go for the y1 bus number 1, so having only one line that is connected y13, because dotted line that is not we have to connect it for the case number 1. If we will go for the case number 2, in that case only we have to consider dotted line. So for the bus number 1 having only one line number only one line that is connected from 1 to 3, which is considered as y13. So y11 that is equal to, we will write y13, and already we have calculated the value of y13 that is equal to 1.0 minus j 3.0. So this is the answer for the y11. Now go for the y22. So y22 is equal to y23 plus y24. So how we will write that? Y22 is equal to y23 plus y24. So bus number 2 that is connected in between 2 to 4, and second line that is connected from 2 to 3. So that's why we will write that y22 is equal to y23 plus y24. Inside case number 1 we don't have to consider this dotted line, so that's why we will remove this line. So only two line that is connected at the bus number 2, that is the y23 and y24. So that's why equation that is written as y22 is equal to y23 plus y24. And if we will solve this equation, so we will get the answer of y 1.667 minus j 5.0. Then after we will go for the bus number 3. So bus number 3 having a total of 3 lines which is connected at the bus number 1 as well as 2 and 4. So we will write the equation for the y33 that is equal to y13 plus y23 plus y34. So equation for the y33 that is written as y13 plus y23 plus y34. So already we will get we have calculated the value of self admittance, that is for the y13, y23 and y34. So just put the value of all the value of self admittance over here. So and we will try to resolve the equation. Then final answer that we will get for the y33 that is equal to 3.667 minus j 11.0. And last one that is the y44. So y44 that is equal to y24 plus y34. So for that we will go for the bus number 4. So bus number 4 having a 2 lines that is connected from first one that is 2 to 4 and second one that is from 3 to 4. So that's why equation that is become y44 that is equal to y34 plus y24. So that's why y44 is equal to y24 plus y34. Again just put the value of y24 and y34, so which is already put it over here. So we will get the answer for the y44 that is equal to 3.0 minus j 9.0. So up to now already we have calculated the values of self admittance as well as mutual admittance, and whatever the value of self admittance and mutual admittance, that try to put inside the actual Ybus. That is the Ybus, that is the y11, y12, y13, y14, y21, y22, y23, y24, y31, y32, y32, y33, y34, y41, y42, y43 and y44. So we will get the answer for the Ybus is equal to 1.0 minus j 3.0, 0 minus 1.0 plus j 3.0, 0, 0, 1.667 minus j 5.0 minus 0.667 plus j 2.0 minus 1.0 plus j 3.0 minus 1.0 plus j 3.0 minus 667 plus j 2.0, 3.667 minus j 11.0 minus 2.0 plus j 6.0, and last row that is the 0 minus 1.0 plus j 3.0 minus 2.0 plus j 6.0, 3.0 minus j 9.0. So this is the answer of the Ybus for the case number 1. This is the answer of the Ybus for the case number 1. Now we will go for the case number 2. This is the case number 2. So inside the case number 2, what is the main aim? So inside the case number 1, that is the what modification is needed to be carried out in Ybus if the line shown dotted is connected. So inside the case number 2, if the dotted line that is connected from 1 to 2, so at that time what is the effect on the Ybus? So only effect that is occur in between bus number 1, that is the Y11, then Y22 and 122, third one that is the Y12. So only there are 3 parameters on that it can affect. So now we will go for the solution for the case number 2. So first one, that is the Y12, that is connected from a dotted line that is connected from bus number 1 to 2. So that's why which is written as Y12 is equal to 1 upon Z12, and value of Z and the value of impedance that is given, for the impedance of bus number 1 to 2, that is the j 0.05 plus j 0.15, and if we will try to resolve the equation, so we will get the answer 2.0 minus j 6.0. Then second parameter of Y11. So Y11, that is equal to, up to now inside the case number 1 we have assumed only one line that is connected over here inside the case number 1. But if we will go for the case number 2, in that case there is a one more line that is added at the bus number 1, that is the dotted line that is added at the bus number 1. So that's line we have to also consider at the bus number 1. So that is the Y11, that is equal to Y12 plus Y13. So already having a value of Y12 and Y13, so just put the value of Y12 and Y13, so we will get the answer 3.0 minus j 9.0. Then go for the next one, that is the Y22. So Y22 at the bus number 2, inside the case number 1, only 2 line that is considered at the bus number 2. But if we will go for the case number 2, in that case we have to assume this line that is connected in between 1 to 2. So that's why there are a total of 3 lines that is connected at the bus number 2. So equation which is written as Y22 is equal to Y12 plus Y23 plus Y24. Already having a value of Y12, Y23 and Y24, and just put the value of all 3 parameters, so we will get the answer for the Y22 is equal to 3.667 minus j 11.0. And then after second parameter, that is the Y2, if we will consider Y21. So Y21 and Y12 both are same, but we will write that Y21 is equal to minus Y12. So we will get the answer of Y21 is equal to minus 2.0 plus j 6.0. So this is the answer for the Y21. So now just put the value of all the parameters in the Ybus. So modified Ybus, which is written as 3 minus j9, 2 minus j6, minus 1 plus j3, 0, minus 2 plus j6, 3.667, minus j11, minus 0.667 plus j2, 1 minus j3. Third row, that is the minus 1 plus j3, minus 0.667 plus j2, 3.667 minus j11, 2.j6. Fourth row, that is the 0, minus 1 plus j3, minus 2 plus j6, 3 minus j9. So this is the new Ybus that we will get for the case number 2. So after completion, after getting the Ybus, this is the answer for the case number 2 for the Ybus. So this is the finishing of the example number 3. Now we will go for the some example which is asked inside the GTU papers. So we will go for the question from GTU papers. First one, that is the form Ybus for a given power system shown in figure, which is asked inside the year of winter 2019 and having a marks of 7. So this is the different pattern of the example, and this is given over here. In that case, having a value of imaginary part, that is given only. There is not any value of the real part which is given over here. Now go for the second question, that is the following figure shows a simple 4-bus system. This is the example that is already we have solved today in today's lecture. So this is the solution for this example, which is asked inside the year of summer 2019 and having a marks of 7. This is the value of conductance and susceptance that is given over here. So from today's lecture, we will learn about some of the example with the different kind of pattern. It may be a 4-bus, it may be a 3-bus, or it may be a 5-bus. And from that, how we will formulate the Ybus. So that we will learn from today's lecture. So in the next lecture, again we will go for the some example that is based on some new method with the help of singular transformation method and bus incidence matrix, and we will go for the example that is based on that two method. Thank you.